All right, hello, ladies and gentlemen. It's Mr. Pouts, and I'm going to go through the practice test for Chapter 4. So go through as much of it as you want to. Skip around if you need to. Check the different ones that you have questions on, but use this as a resource to help you study, help you prepare for the actual test itself. So, all right. So Section 1 is all about relating graphs. So taking a situation and graphing it. So we're gonna sketch a graph and label. Make sure we label and title this graph. So the first one says the temperature of water decreases over the first few hours in the refrigerator. So the temperature of the water decreases over the first few hours in the refrigerator. So we're gonna have time, so hours. Oh, and the temperature of the water. So we're gonna have water temp as our title. So we're gonna say it starts up here and it's just gradually decreasing. And I don't know if it's ever gonna go down to 0, but we'll maybe level out over there. Alright, nothing too much to that one. Second one says the temperature changed as Shelly preheated the oven, cooked bread, and turned off the oven. So again, we're gonna use time again. This time we're gonna deal with the temperature. Well, again, so we're gonna call this oven temp. So chances are it started pretty low. Right, depending on how you're labeling this. She preheated the oven. I'm guessing the temperature went up to its hottest. And maybe when she put the bread on, it went down, but then it went back up to where it would go. And then she turned it off. So it probably stayed there for a while she was cooking bread. She turned it off, and then it gradually went back down to where it started. All right, so up here is where, again, where it was in the oven, where the bread was in the oven. So we have labels, we have titles, and we have a graph that makes sense. That's section 1. Section 2, we're just looking for patterns in tables, graphs, equations, and so forth. So it says, for each table, determine whether the relationship is a function. Then represent the function using words, an equation, and a graph. So I'm going to graph it first, because we can just use the vertical line test to see if it's a function. So why not do that? So we're going to graph it. 0, 4 means we're going to go 0 over, and then 4 up. 1, 2, 3, 4. Second one is 1 over and 3 up. 2 over and 2 up. 3 over and 1 up. And it looks like that's going to create this line right here. Now remember, to check if it's a function or not. We know it's linear, but if it's a function or not is to check the vertical line test on the graph. That's the easiest way. So we take a vertical line. And if there's anywhere that you can move this vertical line so that it crosses more than one point, then it's not a function. But if I go like this, it doesn't cross more than one point anywhere. So yes, it's a function. All right. Now, what's the pattern? What's the equation? What's the pattern in words? So let's look at the equation here. Let's look for the change in y over change in x. So that's going to be minus 1 every time. And that's going to be plus 1 every time. And it does it every time. Minus 1, plus 1, plus 1. So we have y equals something times x plus something. And that something that goes in here is the change in y over change in x. So negative 1 over 1. Alright, and one easy way to figure out what you add at the end is where x is 0. The y is 4, so we're going to add 4 in the end. Otherwise, the other way to check is to plug in. So we plug in, let's say 0. Negative 1 times 0 is 0, and you'd have to add 4 to get to that y. We could go all the way down to 3 and plug in 3. Negative 1 times 3 is negative 3. Plus 4 would be 1, and that's what it's supposed to equal, so there's our equation. Now in words, I'd like you to say something along the lines of, as x increases by 1, y decreases by 1. So there's the pattern that's there. All right, let's look at the second one, number 4. Let's plot those points and see if it's a function first of all. So we're going to graph 2 and negative 6. So 1, 2 to the right, and down 6. 1, 2, 3, 4, 5, 6. 0, 0. Negative 1, negative 5. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Negative 1, positive 5. All right, I don't think there's any way to connect the dots to make that work. And before we try to make an equation or anything, let's look at this. Right there, it does not pass the vertical line test. There's 2 points on that line, so that means that it's not a function. Look at that vertical line. So not a function, so no equation could work. All right, in words, there's really no pattern, so there's no words. Other than saying there's no pattern. All right, that we can tell at least. So from the information we have, there's no pattern. So that's section 2, looking at whether it's function or not, writing an equation, and graphing points. So on to section 3, you can fix section 3 yet on this page. Section 3 is patterns and nonlinear functions. So it says graph the function shown by the table, tell whether the function is linear or nonlinear. Okay? You maybe have to explain, but I think we're pretty good at that. So let's graph these. Looks like we're all in the positives here. So 1 over and 0 up. So this right here is 0, 0. That's the origin. All right, 2 over and 1 up. 3 over and 8 up. 1, 2, 3, 4, 5, 6. Wow, this doesn't fit. So I think we're going to have to change this and go up by 2's. So we're going to make this 1, 2, 3, 4, 5, 6. We're going to make this 2, 4, 6, 8, 10, 12, 14. So we'll plot the points 0 or 1, 0, 2, 1, 3, 8, 4, 20. So that's going to be like way up here. So we look at this, connect our dots, and that right there, it's going to be a function because it'll pass the vertical line test, but it's nonlinear, does not make a straight line. Let's try the second one. Looks like the y's are going up. We'll do the same thing. 1, 2, 3, 4, 5, and so forth. We'll do 0, 2, 4, 6, 8, 10, 12. Oop, don't move that. 14. So if I plot these, 1, 0 is going to be there again. 2 and 4.5 are right there. 3 and 9 right there. 4 and 13.5 are right there. You look at this, this makes a nice line. So it's definitely linear, straight line. All right, number 7 and 8, each set of ordered pairs represents a function. Write a rule that represents the function. This is the tough part. Okay? Right now I'm going to put them into t-charts just to see if that'll help. All right? Our x's and our y's, because sometimes that helps, especially when we're looking for the change in the y over the change in the x. So you have 0, 0, 1, 3, 2, 6, 3, 9, 4, 12. All right, for this one, I think we have a positive 3 change every time in the y's, as that goes up by 1. So the change in y over the change in x, as we talked about before, is 3 over 1. So if we make our equation, we have y equals something. Since this is going to be linear, it has a constant change in y over change in x. We can make it in this form. So the change in that 3 over 1 goes right here. And if we plug in a number, let's plug in 0. 0, 3 times 0 is 0, plus 0 would get you 0. So let's see if that works for another one. Plug in 1 for x. 3 times 1 is 3, plus 0 would get you 3. So there's your equation. Y equals 3, or 3 over 1x, plus 0. All right, so let's look at this one. Let's see if there's a pattern in this one. We'll make a t-chart again. 1, 3, 2, 9, 3, 27. Oop, not going to be linear, I don't think. 4, 81. And then 5, that's another one. So it looks like it's multiplying by 3 every time. We didn't talk about these a lot. Then we just talked about how you're going to have to find a way to make that work when you're multiplying as these go up. Again, these are going, oh, interesting. These are going up by 1 still. So since it's multiplying by 3 every time, this one's a unique one, and maybe this will help. But it's going to be y is equal to 3, since 3 is being multiplied, raised to the x power. So every time, whatever the x is, so if you raise 3 to the first power, 3 to the first power is 3. If you raise it to the second power, 3 squared is 9. So the third power would be 27, to the fourth power, it's 81. So in this case, this would be the equation that would work. Okay, those are hard to come up with. You just kind of have to play around with it. So we're going to move on. We're going to move on to the second page of the practice test on to section 4, which is graphing a function rule. So it says title, label, and graph each function rule. Tell whether the function is continuous or discrete. So lots of parts to this. So number 9 says the cost D in dollars for a parking pass depends on the number of whole weeks W you purchased. So this situation is represented by the rule D equals 25W. So since W, if you look at that, is the number you can plug in, that's going to be our X. So W and D. So what we do with this D equals 25W. If you recall, we pick values for D, or for W, or for the X, and it's going to have to be 0 or positive. So we're going to do at least 3. Just says, doesn't say how many you have to do, so we're going to do at least 3. And we're going to plug in. So 25 times 0 equals 0. So we have the point, so this is 0. Let's do, these will go up by 1s, 2s, 3s, 4s. So that's our weeks, our W. All right, and D is going to be dollars. And this is going to be parking pass. Parking pass. All right, let's try 1. 25 times 1. Well, that's going to be 25. Now 25 times 2. That's going to be 50. So that constant change, it's going to be linear. We'll make it go up by 25s every time. Why not? 25, 50, 75, and so forth. And if we graph those 3 points, we have 0, 0. We have 1 week is going to be $25. 2 weeks is going to be $50. If you're going to continue this, this will go on forever like that, and it'll be graphed like that. And I'm going to actually undo that last part, because we don't know yet if we should connect the dots. We're going to see if it's continuous or discrete. So it says, tell whether it's continuous or discrete. Would you connect the dots? Could you pay for like a half a week? If we look at the situation, it says they're based on the number of whole weeks. So you cannot have half a week. So this is a discrete graph. You do not connect the dots. All right, that's number 9. Number 10 is a little bit different. It says the price in dollars for apples depends on the weight in pounds of the apples. So we just said right there, the price depends on the apples. So we'll do price on this side of the graph, in pounds. This is going to be apple price. So we're going to have W, and the price is going to be right there as well. So if the weight, here's the function rule, P equals 199W. So let's just say you buy a pound of apples. 0 pounds of apples, 1 pound of apples, 2 pounds of apples. We'll do that again. If you plug in 199, if you plug in for W, plug in 0, it's going to be equal to 0. No dollars for no pounds. 199 for 1 pound, well, we'd have $1.99. All right, so it's $1.99 per pound, I can tell. So 2 pounds, it would end up being $3.98. All right, now it depends on how you want to label this. So we're going to do 1, 0, 1, 2, 3 pounds. We'll do 0. I think I'm just going to go up by 2 since it's about that. 2, 4, 6, 8, 10. All right, if we graph it on there, 0 pounds again is $0. 1 pound is $1.99, so just under there. 2 pounds is $2.99, so just under there. It's going to continue like that. Now, Do you think we could have a half a pound? Does it say you can? Does it say you have to buy it in exact pounds? I don't think so. So we could have half a pound. We could have a quarter of a pound. We could buy 1.5 pounds of apples. So this is going to be a continuous graph since we are going to connect the dots then, because you can have those in-betweeners. Alright, then the second part of this, it says make a table of values. This is just a general graph. We're going to leave the graph going by ones. That says make a table of values, graph the function rule, use at least 4x values. Alright, so let's do that. So x and y. So if we plug in, we should always use a negative value. So we're going to use -1, 0, 1, and 2. Alright, let's plug it in. The absolute value of -1 is +1. It's always making it a positive. When we subtract 2 from that, we end up getting a -1. So our first point is -1, -1, right here. Let's plug in 0. Absolute value of 0 is 0. Minus 2 would be -2. So 0 over and down 2. There we go. Alright, next one. Absolute value of 1. Minus 2. So that's +1 still. Always making it a positive. Minus 2 would be -1. So we have 1 over and down 1. And we have one more. Absolute value of 2 is 2. Minus 2 would be 0. So again, this one would be 2, 0. If you want to make a column for the ordered pairs, that's 2, 0. So you know 2 up. Alright. And again, this one would be 1, -1, and so forth. It looks like we have our graph. We can connect the dots and continue the arrows. Whoops. We can tell it's an absolute value graph because it makes the V, and we have absolute value in there. All right, let's do the second one. I won't talk so much during the second one. Just going to work it through. You can look at it how I would do it. All right. We'll do 1, 2. So again, -1. That's the opposite of -1. So it's going to be +1 plus 3 would be 4. So we have the ordered pair -1, 4 on that one. Let's do -0 plus 3. It's still going to be 0. Okay, 0, 3 is right there. Let's do -1 plus 3 will be 2. So 1, 2. And -2 plus 3 would be 1. So 2, 1. And there's our graph. Looks like it's a linear one. And there we go. All right, that's section 4. Now, section 5 was writing a function rule from words. We got 2 problems there. It just says write the function rule that represents a sentence. So, cubes. Circle the number. Underline the question, which we know is right there. Box key math action words and write an equation. Whoa. And solve if need be. So we're going to circle the numbers. 1 more than 2/3 of A. So we have 1. That's plus 1 more than 2/3 of A. 2/3 of A would be, oh, underline, more than, of, is. Of is multiplication, so 2/3 times A is equals B. Alright, there we go. Circle again. 6 times the sum of a number t and 5. Okay, we're going to underline times. Sum. And would be with that sum. And is. So 6 times the sum of a number t and 5. So we're going to do t and 5. T times 5 would be, oh, the sum of a number. So it would be t plus 5. So 6 times that is, all right, let's not get our 5s and our s's mixed up. There's s. All right, so 6 times the sum of a number t and 5, so that's t plus 5. 6 times that is 6. There is s. There we go. So remember, circle the numbers and underline or box the key. Oh, I should have been boxing these. I'm breaking my own rules. Sorry. Underlining the question. As long as you get the point that you're looking for those key things. All right, moving on to section 6 and 7. Section 6 might be one of the harder sections, so listen up. Take note on this. It says identify the domain and range. So domain is all the x's. Range is all the y's. For each section, use a mapping diagram to determine whether the relation is a function. So this would be your x's and this would be your y's. Now, the domain, if there's any repeats, remember you don't repeat them. But so the domain would be we have -3, we have 0, 1, 2. So we'll put -3, 0, 1, 2. The range, we have 6, 2, 0, -3. 6, 2, 0, -3. They're all 1 to 1. So you draw your arrows. They're all 1 to 1. That means it is a sure sign that it is a function. If you graphed them too, if you graphed all 4 of them and tried the vertical line test, you'd know that it's a function. All right, next one, domain, we have -1. Remember, they're all the x's. 0, 1, 2. The range is all the y's, so we have 4, 0. Oh, there's a repeat, so we have to repeat it, so we have an 8. So -1, 0, 1, 2, 4, 0, 8. 0 goes there, 0 goes to 0, 1 also goes to 4, and 2 goes to 8. Now you might be looking at this and thinking, there's a repeat of y values. Does that mean it's not a function? No, if there's a repeat of x values, if you have a repeat of x values, it's not a function. Otherwise, it's okay, because it'll still pass the vertical line test if you graph it. Always check with the vertical line test if you're not sure, but this one is a function. All right, so the second part of this is we're taking, I think we're taking range values and we're trying to find the domain depending on what we're working with here. So if we're looking at this, 17 is actually going to be multi-stepped. 17, so I'm going to make it into a T-chart right here. Because we're given the range, or we're trying to find the range given the domain. So the x's were given, the y's were not given. So we have -2, -1, 0, 3, and 4. So we take those numbers and plug them in for the function. We're going to do -2 squared minus 7. So that would be -2 times -2 is 4. That's going to be -3. 4 minus 7 is -3. Let's do -1 squared minus 7. -1 times -1 is 1. And that's going to be -6. All right, 0 squared minus 7. 0 minus 7 is -7. Stay there. All right, how about 3 squared minus 7? Things are moving on me now. All right, that is 9 minus 7 is going to be 2. And then we have 4 squared minus 7. Wow, this is weird. It's going to be 16 minus 7, which is 9. So the range would be right here. We have -3, -6, -7, 2, and 9. All right. Now number 18 is doing the same thing. It's saying the function where x is -5. So we're just doing it with one value. So if we know f of x is -9x minus 3, f of -5 would equal -9 times -5 minus 3. And that would be -5 times -5 is 45 minus 3, which equals 42. All right, and then number 19, use the function. We have two different functions, and we want to find f of x, or f of 2 plus f of, or g of 5. So f of 2 would be 2 times 2. Sorry about that. Which equals 4. G of 5 would be 5 squared plus 1, which would be 25 plus 1, which is 26. So that plus that would be equal to 30, since we're trying to find f of 2 plus g of 5. All right, well, very last section, arithmetic sequences. We love arithmetic sequences because they're just finding there's a common difference between each number if it is an arithmetic sequence. So let's see right here. This is going to be minus 4, minus 4. I don't know why it keeps doing this to me. Minus 4, minus 4. So yes, and the common difference is negative 4. Alright, let's try this one. Plus 3, plus 4, plus 5, plus 6. Not arithmetic, because it's not going up by the same amount every time. There definitely is a pattern, it's just not an arithmetic. Alright, find the 4th, 6th, and 13th terms of the arithmetic sequence. Alright, so really we're given the formula already. And we're just going to plug in for it. So we're going to find the 4th, we're going to find the 6th, we're going to find the 13th term. So we're going to plug in for the n. 6 plus, we're going to do n minus 1, ooh, times negative 1. And if you're wondering, we'll do the same thing here. 6 plus, instead of n, sorry, we're going to use 4. This one we're going to use 6 minus 1. Cheapers. Times negative 2. This one we're going to do 6 plus 13 minus 1 times negative 2. Now if you look at this, you can tell the starting point in this sequence is 6. And the common difference is minus 2 each time. So if we do this right, we'll do the parentheses first. So it'll be 6 plus 3 times negative 2. Then we'll do the multiplication. So it's going to be 6 plus negative 6, which would be, we do this first, and then we do this, 0. 6th term, we're going to do the parentheses first. So it's 6 plus 5 times negative 2, which then we do the multiplication next. So 6 plus negative 10 would be negative 4. And then finally, keeping with the order of operations, 6 plus 12 times negative 2. Come on. Alright. 12 times negative 2 would be negative 24. 6 plus negative 24 is negative 18. So there's your 3 terms. There's the practice test. Alright, that is the Chapter 4 practice test. Hope it helped. Hope you can use it to study from. Good luck on the test.